The scores follow a normal distribution, and how would you describe a normal distribution and so on. So a normal distribution, you're gonna have this like bell-shaped curve. The peak of the curve right here, this is gonna be your mean, which usually uses this is called mu. So this is your mean. So when someone says scores or something follows a normal distribution, it just has this bell-shaped curve. Your variance, which is something else you'll learn about, determines how dispersed. That sucks. Determines how dispersed your values are centered around the mean, right? So this one would have a smaller variance than this one, right? Because it's got a higher peak, right? So the steepness of the peak is higher. Question 2. It says, would knowing each professor's final exam distribution in a normal convince you that both courses are equally challenging? Not really. So remember, you have what I was just talking about with the variance, right? So if you had a very small amount of variance, right? If you had a very small amount of variance, your curve would look like this, right? Which would mean your scores, your average score, and all the other scores for the rest of the class are very closely tied together around this your mean, or the average score. Now, if you had a very large amount of variance, you'd have much more dispersion of your scores, right? So this would indicate a curve like this would indicate that most people in the class scored right around this average, right? So you might have, this is pretty terrible because I'm only going to use 3 numbers, right? Let's say you had a score of 7, an 8, and a 9, right? Well, this is going to be your average, and your other 2 scores are really close to it, right? So everybody's really close to having that. Now, if you have, let's say somebody had a 5, a 10, and a 15, you're going to be, the values aren't as close to the 10 as they are up here close to the 9, right? Because this would be your average. So you have more dispersion, which tells you that some people did much better than the mean than others did. Also, just knowing that it follows a normal distribution isn't going to tell you really much, other than this is how the grades fall. Because you could have a mean that's at, let's say this class's mean is, let's say all things equal, right? Let's say all things equal, and the dispersion is the same. Let's say that these 2 curves are the same, right? Well, if this mean here is at, let's say like a 90, right? But this mean down here is at a 70. Well, they have the same dispersion, right? But the averages, dispersion is in the variance, sorry. The averages, well, this mean's higher than this mean, which would say that this class is do a lot better than this class, right? But so unless you know the mean and the variance, it really doesn't matter in terms of telling which class is more difficult than the other. Let's see the next one. Let's assume, okay, I didn't even see that before. Okay, so an A, so a couple quick notations I'm gonna make. So this right here, a mu is equal to the mean, right? You have, this is called sigma. So sigma squared is known as your variance. And then just plain old sigma, that's your standard deviation. And then over here, a score, an A is at 90. This is right on your paper. An F is at a 60. So what we want to do with these is we want to compute your z-scores, right? So to compute a z-score, we're going to have X bar, which is going to be the number that we're going to look at. So, for instance, when it says in question 5, it says what's the probability of getting an A? We're going to take that A, which is a 90, or that's going to be our X bar, minus our mu, which is going to be our average, and then we're going to divide it by the square root of our variance. Now, just for like quick notation, I could just put sigma here. I don't know how good your algebra is, so I'm just going to write this out. Sigma squared is the same thing as writing sigma times sigma, right? Now, if I take the square root of that, I'm going to have just sigma. And to make that a little bit more clear, let's say I had, let's say this is 16, right? If 16 is equal to 4 times 4, if I want to find the square root, I know that the square root of 16 is 4, because 4 squared is 16. So if that makes sense, right? I'm just going to write it, I'm just writing it like this, because you're normally going to see it as the square root of the variance. So the first one, the number, I already explained to you 3 and 4 yesterday, or I can in a second. So what's the probability of getting an A in Dr. Johnson's class? So I'm going to, let's kind of break this out, right? Let's write Johnson. Who's your other teacher name? What's the other teacher's name? Doctor, I don't know because it's cut off. So, Doctor, let's just call him Jekyll because I can't see the other name. J-E-C-K, I don't know how to spell Jekyll, whatever. What's the probability of an A in Johnson's class? So, Johnson. In Johnson's class, we know that the mu is equal to 76. And we know that, we know that sigma is equal to 7. So I guess I could rewrite this since they're giving you sigma. So what's the probability of getting an A? So to get an A, we know the z-score is going to be, so we want A, we know our X bar is going to be 90. So we have 90 minus the mean, 76. Divided by sigma, which is 7. And then the probability of getting an F, this is for an A. I'm just going to put a little A here. The probability of getting an F, what's the F number? F is a 60, right? So 60 minus 76 over 7. Now, something to note, right? So in order to get an A, what we're looking at here, 76. We want to know what's the probability of getting an A. Now an A is at 90, right? So we have 90 here. This will be your score. What we want is this value here. What a z-score tells you, if I was to put this value on the z-score, it would give me this amount. Right? But we want this. So what I actually have to do is, I have to take 1 minus the z-score of 90 minus 76 over 7. Okay? And then this one, this z-score, this is going to give me up to here, right? Which is what I want. Because we want to know what's the probability of failing. Is everything this way of that number, of that 60, this is failing, right? Likewise, if I was to look at this one where it was 90, everything over here is passing, right? I'll come back to that in a second. Now, over here on your other guy, what the fuck was the number? Okay. He's got a mu equal to 70, and a standard deviation of 16. So the z-score of getting an A is going to equal, and I'm just going to do it from the start, 1 minus what was it, 90 minus 70 divided by 16. And the z-score of failing is what, 60? 60 minus 70 over 16. I wanted to show you how looking up in the z-score, the z-table, how it's going to equal what's the R code, right? So the probability of getting an A in Dr. Johnson's class was, we had to compute this, which came down to 1 minus the z-score of 2. So what we want to do is we want to come over here to the positive side of the z-tables. We're going to find a 2. And so we had just plain 2, so 2.0. And then you see this column here is 0, 0. So we got 0.9772. And since we wanted an A, which is everything above it, or to the right, and the table is showing us everything to the left, what we want to do is subtract it from 1. So 1 minus 0.972, sorry, and we get 0.0228. And we can kind of do the same thing on all of these, and I kind of skipped that by accident. But you'll have the z, what's 60 minus 76 divided by 7, negative 2.28. So this one should have been, we want a z of, my pen's dying, negative 2.28. Which negative 2.28, so we come over here to the negative side, negative 2.28.0113. Actually, it's 0.85, so we would take the average of these two. We could add them and then divide it by 2. So really all I did was, that's what you got here. And then same thing here. This is how you set it up, 1.25, do the same thing over here. Look up 1.2, come over to your 5 value, and then you just subtract that. And then we do the same down here. Now, as far as your R code, once you open up R, and I already inputted everything, if you open up R and there's no console to put in text, just come here, new file, and you want to run a new R script. And then the code for it, so looking at the first one, we want to find the probability of an A. We want 1 minus that z-score. Instead of doing all the division out by hand, so to get a z-score, the probability from a z-score is probability of a norm. So 1 minus p norm, 90 minus 76 divided by 7. So I set all these up in here, right? And then if you look down here, because I ran it a couple times, 1, 2, 3, 4. So the p norm, we want to be, my finger's messing up the zoom on it. So so up here we enter the code, and once you enter in the line, when you're to the right, or all the way, when you're in that line, if you come over here and hit run, it's kind of like hitting enter on a calculator, and it'll compute the number for you, or whatever you have entered up there. So let's take these last 4, 1, 2, 3, 4. Here's what it'll show you. So like p norm of 90, right? It's up here. This will tell you, 1, 2, 3, 4. This will tell you your answer. So your probability is 0.0227, right? That's 1 minus p norm of the probability from normal distribution of this amount is 0.111 whatever. So I wrote all those out here. Here's your here's how you put it into R. 1 minus that amount would give you this. And as you can see, these two numbers are the same, just about, right? It's it has to do with how you entered it in or how you looked it up in the chart. Same thing here. Here's your R code for finding a failure in Dr. Johnson's class. Here's how you enter into R, and then there's your value. Same thing over here. You see these numbers are matching up. I'm just showing you that there's 2 different ways you can find your answers.